Okay, so example 1. Again, this is just a special case of what we've already been doing. So then on this one right here, you should see that, what's A on this one? Yeah, it's a 1, right? So A is the number out in front of x squared, so that is a 1 right there. So then on this one, we know A equals 1, B equals 4, C equals 4. All right, so then we're going to need two numbers that multiply to A times C. So what would A times C be on this one? 4. So that would be a positive 4. And then the same two numbers need to add up to B. And what's B on this one?
4.
Positive 4, yep. So then what are two numbers that multiply to 4 and add to 4?
2.
Yeah, positive 2 and positive 2. And then in this case, since A is 1, all we've really got to write here then is just, it'd be 1x and 1x, right? Since A is 1. But 1x is the same thing as x, so I'm just going to write x. All right, and then it's a positive 2 and a positive 2. So I write plus 2 and plus 2. And then do you guys see that those are identical? Those binomials are the same. So I could then write that as the quantity x plus 2 squared. And that's the reason it's called a perfect square trinomial. It's because these two binomial factors are identical. All right, so that's it for 1. Let's try 2. So 2, same thing again. We have that A is 1. So then on this one we have A equals 1, B equals what?
49.
Negative 14. And C is, what's C? Thank you. What did I do here? So C is 49. All right, so then for this one, we're going to need two numbers that multiply to A times C,
49.
which is 49, positive 49. And then same two numbers have to add up to B, which is negative 14. So what are two numbers that multiply to 49 that add to negative 14?
Negative 7 and negative 7.
Yep, that's good, guys. So negative 7, negative 7. So again, negative 7 times negative 7, that would be a positive 49. And then negative 7 plus negative 7 would be a negative 14. And again, A is 1 on this one. So then we would write 1x and 1x. But that's just x. And then it's a negative 7, so we'd write minus 7 and minus 7. And again, you can see that those are identical binomial factors, so then you know that that's a perfect square trinomial. This thing right here. This original problem then, that's called a perfect square trinomial. So then you could write your answer then as the quantity x minus 7 squared. And that would be it for that one. All right, let's try 3. So number 3, again, A is 1. So you have A equals 1, B equals 10, C equals 16. So we're going to need two numbers that multiply to A times C, which would be a positive 16. And then the same two numbers would have to add up to B, which is positive 10. So then what would you guys get for this one?
8 and 2.
8 and 2. You got a phone there for me, buddy? No? I'll put it on the desk behind you.
Oh, I know this. I don't want to do that. That's here. They like grab this.
So what did you guys say?
8 and 2.
8 and 2? Yeah, so positive 8, positive 2. So positive 8, positive 2. All right, so then again, A is 1, so we would have a 1x and a 1x. And then we got a positive 8 and a positive 2. So then we would write plus 8 and plus 2. Now, is that a perfect square trinomial then? No. No, those are not identical. I mean, it does factor. So you still factored that quadratic trinomial into those two binomial factors, but they're not identical factors, so it's not a perfect square trinomial. All right, let's try 4. Now, before we do 4, I want to remind you of the last one on the last example we did yesterday was number 8. And I'm just going to kind of redo it over here on the side. So what we had on number 8, if you remember from yesterday, is we had x squared minus 16, right? And the way we did that is the same way we did all these, right? We just considered the b to be 0. But there's a little bit of more of a shortcut you can use to do these. And how you want to look at this is something squared minus something squared. Does that kind of make sense? So it's x squared minus 4 squared. Well, that's called the difference of two squares. Difference means subtract, so you have to definitely have this subtraction right here. Otherwise, this method won't work. And as soon as you write it like that, then you can just write the answer right away. So the two things that are getting squared here are x and 4, right? So one of the binomial factors is going to be x plus 4, and the other one is going to be x minus 4. That's the same answer that we got yesterday. And you should see that that works, right? Again, those two factors are identical, except one has a plus in the middle and the other one has a minus. And when that happens, like when you multiply, well, obviously if you do the x times the x, you'll get x squared. But then if you multiply these two together, you get negative 4x. And if you multiply these two together, you get positive 4x. And if you add those together, you get 0x, so it cancels out. That's why there's no b. All right, b is 0. And then you would do the positive 4 times the negative 4, and that would give you the negative 16 right here. So that's how we're going to look at these now. It'll just be easier this way. So let's go back to number 4. So on number 4, what I want to ask you guys then is like, let's see. So we have something, hold on. We have something squared. Oh, I hit the wrong thing again. We have something squared minus something squared. That'll be the difference of two squares. So what would you square to get 4x squared?
2.
2 what?
2x.
Yeah, 2x. So you would square 2x, right? 2x times 2x would give you 4x squared. And then what would you square to get 1? What's that? Yeah, just 1. This will be a 1 right here. All right? And then, again, you have to have this minus in the middle, okay? It has to be a subtraction. And as long as you have that, then you can just write the answer right away. So the answer for this one is just going to be 2x plus 1 times the quantity 2x minus 1. So again, you can just go to that answer right away. So what you're looking for in these problems, in terms of the numbers at least, is you want these numbers here to be perfect squares. All right? The perfect square numbers are like 1, because that's 1 times 1. 4, that's 2 times 2. 9 would be 3 times 3, right? So you'd be looking for numbers like that, 16, 25, 36, 49, 64, 81, 100. So that's what you're looking for in terms of the numbers. All right, so then we are on what now, 5? Is 25 a perfect square? Yeah, because it's 5 times 5, right? Okay, so let's do this one then. So now we're going to set it up the same way. So we're going to say this is something squared minus something squared. So what would you square to get x to the 6th? It'd be x to what power? What's that to be? X to the 3rd, perfect. Because you guys got to remember when you have a power raised to a power right here. Hold on, I got to make that look like a 3. So when you have a power raised to a power right here, you multiply these exponents, right? So you do 3 times 2 would give you 6. And then what would you square to get 25? Yep, that's a 5. And again, it has to be a minus in the middle or this method doesn't work, okay? If it's a plus in the middle, you can't do it, okay? All right, so those are the two things that you square, x cubed and 5. So then you know right away your answer is just x cubed plus 5 times x cubed minus 5. So once you see that pattern, those are pretty quick. That's your answer on that one. And of course, remember when you guys take the quiz on Friday, you can always multiply these out and check. So if you do the x squared the x to the 3rd times the x to the 3rd, well, there you would add the power, so you would get x to the 6th. And then if you multiply these two together, you get negative 5x cubed. If you multiply these two together, you get positive 5x cubed. If you add those together, that's 0. They cancel out. And then you would multiply the positive 5 times the negative 5, which would give you the minus 25 or negative 25 right there. All right, 2 more to go. Now, again, you're looking for perfect square numbers, so 4 and 100 are both perfect square numbers, right? 4 is 2 times 2, 100 is 10 times 10. You have to have a minus in the middle. And then also on these, notice they're all 2 terms, right? If you're looking, so when you guys get your quiz on Friday, the first thing you're going to think of when you see 2 terms is you're going to think of the difference of 2 squares. Okay? So again, this only has 2 terms. So it's not a trinomial, it's a binomial. Okay, so then again, we're looking for something squared minus something squared. So what would you square to get 100x squared? Well, first of all, what would you square to get 100? What's that? Yeah, good, Tom. 10, right? And then what? Here, look, I'll do it in the other color. And then what would you square to get x squared? Yeah, just x. So 10x times 10x would give you 100x squared. And then what would you square to get 4y squared? 2 what? Just 2y, right? Yeah, 2y times 2y would give you 4y squared. And again, you have to have this minus in the middle or it doesn't work. All right, so then you can just write your answer. So it's going to be 10x. So 10x plus 2y times the quantity 10x minus 2y. And then that's it for that one. All right, one more to go. So last one. So number 7. So this one, you know, it's got 2 terms. It's got the minus in the middle. So again, you're tempted to think of this as something squared minus something squared, right? Well, what would you square to get 16x squared? It'd be a 4x, right? And then for that next term, what would you square to get the 4? A 2. But do you see that the y doesn't work? You got an odd power on the y. That's not going to work. Like if that was y to the 6th power, then this would be y to the 3rd power, right? Or like if that was y to the 10th power, this would be y to the 5th power, right? Because again, when you have a power raised to a power, you multiply the exponent. So 5 times 2 would be 10. But this one doesn't work. So you can't do it that way. All right, there's nothing you could square to get y to the 5th power, because that power is odd. But there is something you can do. So this kind of, I like whoever made this packet, because this is trying to get you, actually try to get you ready for the next section. So in the last section of the chapter tomorrow, they mix all this stuff together, like all the different, so they just give you a problem. They don't tell you whether it's a difference of two squares, or whether you're going to factor a trinomial, or if you're going to do factor by grouping, or if you're going to do a greatest common factor. It's just all mixed together. And you got to figure out which method to use. And sometimes you got to use more than one method. You'll do the first method and then it'll factor again. So in this one right now, this method of trying to set this up as the difference of two squares, this is not going to work. But there is a greatest common factor. What's the largest number that divides evenly into 16 and 4? Yeah, it's 4. I think even. So it's a 4. So you can factor a 4 out. Now, is there an x in both terms? No. Is there a y in both terms? No. So your greatest common factor here is just 4. And then so this is back to the ones, remember when we started. I think we did this on Thursday, the first day back from break. This is like doing the distributive property backwards. So 4 times what would give you 16x squared? 4x squared, right? Remember, you can always, if you're not sure, you can always take this term and you can divide it by the greatest common factor. So that should be a 4x squared. And then we'll put a minus in here. And then what would you multiply 4 by to get 4y to the 5th? Good, yeah. 1y to the 5th. That's kind of hard to see that. Supposed to be 1y to the 5th. Like that. That's it. That's all you can do with that one. So all you're able to do here is you factored out that greatest common factor. That's the GCF. All right, and that wraps